Hello, everybody. We are so excited that you're here. My name is Becky Eldridge. I'm here at Walker. I work in marketing, and I'll be facilitating this presentation. But the real star of it is Mr. Al Bustamante, coming to you from Houston. We'll introduce him in just a second. But in the meantime, if you guys take a look, probably on your right-hand side of the screen, you'll see that there's a chat box. And throughout this presentation on extending the life of your parking structure, we encourage you to throw questions in there. And we're leaving 15 minutes at the end for a Q&A. But if at any point a question comes up while you're looking at a particular slide or hearing Al speak, throw it in the chat and we will make sure we address it. Otherwise, sit back, relax, and I would like to introduce Mr. Al Bustamante.
All right. Well, thank you, Becky, for the introduction. And first off, I'd like to thank everybody for taking the time to join us today for this presentation. As Becky mentioned, the title is Extending the Life of Your Parking Structure. And what we should expect today is about 40 to 45 minute presentation. And then we're going to have some time for Q&A. Certainly, as I go through the presentation, if you have any questions, feel free to type them into the chat section, and then we'll go over those questions at the end of the presentation, and I'll make a point to get back to everybody on all those questions today. If not, we'll follow up later. So in terms of the objectives, or what you should expect to get out of this presentation today, so here's a list of the objectives for today. The first one is proactive investigation and restoration can save money in the long run. So we're going to talk about a proactive approach versus a reactive approach and the advantage to go proactive. Understand the different types of parking structures. I'm going to go over an overview of the typical types of distress conditions that you see in different types of parking structures. The life cycle of a parking restoration project from A through Z. And what I mean by that is the life cycle of a project starts with the planning stage, going into the investigation all the way until the actual construction is executed. So we go through all those steps. The importance of properly determining the significance of the distress and the financial impact. This is a key aspect of this presentation. I'm going to emphasize why it is important to properly assess the significance of a particular distress, because that will have an impact on the bottom line. So we'll go over that through the presentation and also with some case studies. And then we're going to talk about the importance of repair and construction documents and construction phase services. And also at the end of the presentation, after the Q&A, I will mention some of the tools that we will provide to you. We will follow up with some tools that you can use to better manage the maintenance and repairs of your parking facility. So stay tuned for that. Now, in terms of the table of content, we have two main topics and subtopics. So we're going to talk about the asset management approach, which includes the inventory, assess, prioritize, plan, and execute. And then we'll illustrate some of this concept with some case studies. So I have about 3 to 5 case studies. We'll see, depending on time, how many we can go through it, but at least we'll go to 3 case studies, which are basically specific projects to cover these concepts. So first on the agenda, the table of content, asset management approach. So we talked about proactive versus reactive. So on the left, you can see that the firemen try to put out a fire essentially in a reactive mode. So you certainly don't want to be the fireman trying to address, or the fire person trying to address an issue after it has become a problem. So certainly the point that we're trying to illustrate today is the asset management approach, which is the steps that we talked about, starting with the inventory, with the assessment, and the prioritize the repairs, the planning, and then certainly execute the plan. So we'll talk about those steps here in more detail. And the reason for that, bottom line, because it saves money in the long run, particularly if you have a structure that you're going to keep for a long time. This approach certainly is a way to go. And the best way to illustrate that, this graph over here schematically kind of shows the essentially the deterioration curve for a parking structure. So what you'll see here is on the vertical axis is the deterioration and the repair cost. And then on the horizontal axis, the time of the structure throughout the service life. So these curves represent the deterioration of different types of structures from a schematic standpoint. So you as an owner or property manager, what you want to do is try to maintain that curve as flat as possible. In other words, minimize the cost, extend the service life. So to do that, it is very important to go in early in terms of the timing for doing repairs. So on this graph, you can see, I want to direct your attention to point A and point B. So doing repairs when the life cycle is at about point A and bring back down the curve to a more flat type of normal deterioration curve, which is the one shown over here, that is certainly the ideal scenario. Now, if you wait to address the issues on point B, then all of a sudden the cost goes up exponentially. And that is a unique type of behavior of parking structures as opposed to other types of structures where the deterioration curve is not quite as steep. But when it comes to parking structure, the cost goes up exponentially very fast. So certainly getting in early is the way to go. So again, the emphasis is to be proactive, stay ahead of the curve. This one kind of shows it in a more of a cash flow type of graphic. So you start out with the planning and designing construction, then there is operation and maintenance costs throughout the years, then there are renewals, which are essentially the repair programs that are done throughout the life of the structure, and then disposal at the end. The timing of this renewal is key so that you can maximize the service life and minimize the cost. So we'll talk about the optimal timing for do that in a minute. And this graph kind of shows the life cycle cost versus the rehabilitation replacement interval. And essentially what ideally where the area where you want to be is this section shown in the red, where is the ultimate timing for the rehabilitation and replacement. So I'm going to illustrate this with an example. So let's say you have a parking structure where you're dealing with seal and joint on the floor, let's say the route and seal type of repair. If the repair is done at a high frequency every 2 to 3 years, certainly you have a high level of service, but at a much higher cost. If the repair is done here on the right, where you delay the repair, all of a sudden, instead of having just a crack, it can be a spall, it can be a more severe type of distress. All of a sudden, the cost goes much higher, so a lower level of savings and higher cost. So the optimal timing for that particular repair is to do it in such a way where the seal and joint is maximized its service life at a minimum cost. So in this particular example, it's about every 5 to 7 years. So the point here is that the timing of renewal is key to minimize the cost and keep that curve, the curve that I showed earlier, keep it as flat as possible. And many factors, again, affect the effective renewal, including the age of the structure, the geographic location, the type of structure. We'll talk about the types of structure for parking garages here in a minute. The state-of-the-art design. Some of these parking structures, they have a built-in deficiency because at the time that they were designed, we didn't have the technology or as much knowledge about the behavior of these type of structures. There are some inherent deficiencies in the design from earlier times in the 1980s and before, sometimes in the 90s. Also, the concrete cover, it has changed over time as specified indicated by the code. So the higher the concrete cover, the more durability you're going to have on the structure, and that could also be a factor. And then the post-tensioning, which is a specific type of framing, the sheeting has changed over time. There's newer technologies that are more that have a better durability than previous technology. So all these things are items that affect the renewal, and you as an owner or property manager can inherit a structure that has some of these already built-in deficiencies that need to be properly addressed to optimize the timing of when repairs need to be done. This graph over here, this figure, there's a lot of numbers. I don't want to distract you with all the information here. This is just for the purpose to illustrate what the kind of an asset management type of table will look like. And essentially the information that is conveyed here are the opinions of cost for different types of repairs and the timing when they should be done. some items can be done early if they have a higher priority, and some items can be deferred to later. So this is where the proper diagnosis of the type of distress conditions is important, because it allows us to essentially prioritize repair some of the items that need to be done early, but then there are some items that can be deferred for a later time, and all that can be summarized in this type of table. And another key component of this is that the repair cost of your parking structures will be affected by what percentage of the structure is available for the contractor to do repairs. So typically that is addressed in this type of asset management plans. And in my experience, most repair projects, the owners want to maintain the parking structure in service while the repair is being done, for obvious reasons, because of the cash flow that you want to maintain, keeping the structure open. And that does one thing on the operation side, but on the construction side, it increases the cost, because the contractor is only able to do repairs on certain sections at a time. Right now is probably a good time to do repairs on a lot of the parking structure that have not been heavily used because of what's going on with the COVID-19, the pandemic. A lot of these structures are pretty much empty. So from a construction standpoint, it can save significant amount, anywhere between 15 to 20%, because now the contractors can go and have a structure that is open, they can do repairs, and can gain a lot of efficiency. So right now is a good time to do repairs. So now that we went over kind of an overview of the asset management approach, we talked about the proactive versus reactive, the deterioration curve, and so forth, the timing for doing repairs. Now let's go into the different components of the asset management in more detail. The first, so we have inventory, assess, prioritize, plan, and execute. So the first one is the inventory. This graph kind of shows percentage-wise the types of parking structures as a function of the framing. So the vast majority of the parking structures are 52% are precast concrete, about 39% are cast in place post tension, 6% are cast in place concrete with mild steel reinforcement, and there's a small percentage of steel framing. So what I'll do is I'll show you some photographs to kind of illustrate all these different types of framing. And some of these might be basic to some of you, but just for the sake of completeness. Now, the first one shows a cast in place concrete post tension structure one way. This is probably one of the best type of framings that you see out there for the parking structure, because it's very open, very well lit, and the span between the columns is typically 60 feet or so. So they are very open, very effective type of framing for the parking structure. The next one is a cast in place concrete pan joist system. These are typically, you see it in older structures from 1980 and even before. You also see it on the ground parking structures. They are very heavy, lots of concrete, very tight column spacing, 30 foot on center or so. So it makes the turning radius kind of hard to do. So this is not the best type of framing for parking structure, but there are many structures out there built with these type of systems. The next one is very similar. It's also cast in place concrete. It's called a waffle slab because the slab essentially looks like a waffle. If you see here from the photo, I apologize about the resolution. It's a little bit grainy, but that was the best one I could find. But the column spacing is very tight. Again, the turning radius can be challenging to make that happen for this. But there are some parking structure with this type of framing. Next one is precast concrete. This is probably the most common type of parking structures that you're going to see out there, and primarily because they are relatively inexpensive as compared to other types of framing, and they go up very fast. Basically, the way these structures are built, you have all these precast elements, which are the beams and the columns that are made at a precast concrete plant. They are brought to the site in a truck, and they're kind of put together like a Tinker Toy type of thing. It's a lot of connections and miles and miles of sealant joints that need to be maintained. But the upfront cost of these structures are typically less than a cast in place post tension, but the long-term cost could be higher because of the maintenance of all the joints and connections. Next one is a steel frame with a cast in place concrete deck. This one is a little bit of a hybrid. type of structure, not an ideal type of framing, but you see this mostly on vertical expansion of garages. And the reason is because they're very lightweight. So it's an ideal type of framing for a vertical expansion. This particular one has again a steel frame with the casting place concrete deck. This is another type of framing, a steel frame with what's called open web steel joist and a form deck and 3 inches of concrete. This is my least favorite type of concrete structure or steel frame for a parking garage because it's not very durable. They are very flimsy. However, there are hundreds of this type of framing, particularly in Houston. I've seen there are some in Pittsburgh, in Pennsylvania. They're not very common throughout the country, but there are a few cities where you see a lot of these, particularly in Houston, Texas. So, and they have all kinds of problems. So we'll talk more about those later. Here, very similar type to the one that I just showed, but instead of having the open web steel joist, this one has the castellated beams. I don't know if you can see my cursor, but here this arrow is showing these circles in the middle, these holes in the middle. That's what's called a castellated beam, and they do that to minimize the weight and the cost. And this is another type, which is also steel frame, but instead of having beam or castellated beam or joist, this one has a composite deck, which is essentially a metal deck with 5 inches of concrete on top. So anyway, that's a general overview of the different types of parking structures that you're going to see out there. There are some other types that are a little bit more specific, but in general, those are the main types that you're going to see. Now, the next part, we're going to talk about the assessment. So the investigation process, this is a critical aspect of the asset management because this is where we identify the types of distress conditions, and more importantly, what's the significance of those distress conditions. In other words, if you see a crack, how severe is that issue? Is it a structural problem? Is it just a durability type problem? Is it just aesthetics? You know, what's the significance of that distress? So this investigation process allows us to do that and determine the cost implications. In some cases, you're going to find that most of the assessment is visual, and it's not enough to be able to come up with the recommendations. And sometimes we have to do an additional assessment, which typically involves material sampling and testing. And I have an example to illustrate that. The outcome of all this is going to be a report. That's what you as an owner will see. And that report, the way we typically do that is pretty standard throughout for consistency. However, there are some clients that like to have a special format for their reports, and we can certainly accommodate that to whatever format you want to see. Sometimes the cost table, there is a standard cost table that you're accustomed to see, and we'll provide that. Some clients that have multiple properties throughout the country, they like to see the same consistency in reports because you know, they want to see, they want to know, they want to have that consistency. They can always look through the report and always find the information. It doesn't matter where the structure is. So that's also another important aspect of this, is to have that consistency of the reports from a client, from an owner perspective. So now that we talked a little bit about the investigation process, which allows us to prioritize, we talk about the prioritization of repairs. And this is where we know how bad is fat. You know, what's the significance of this? This photograph, for example, shows cracking on a concrete deck. So what cost it and what is it going to take to fix it? This other one looks like a less severe type of cracking, but it's actually a more, this particular crack was on a post-tension structure. And this cracking actually is an indication of a structural problem. So this one is actually more significant than the previous cracking that I show, even though the other one looks worse. So sometimes the way that the distress looks is not an indication of how severe it is. So that's important to understand as well. Here's another example that shows a lot of cracking at a corner of a parking deck. There is a wall and some beams that kind of restrain the movement. So this cracking here, even though it looks pretty severe, is actually non-structural. This cracking here is related to restraint to thermal movement, which the repair for something like that is much less than if it was a structural type problem. This is another one where the cracking in the concrete has allowed water to go through, and you can see some leaching going through. So it presents not only a durability type problem, but also an aesthetic issue. It looks very nasty. In this case, water goes through the crack and it picks up minerals, and then you can see that leaching going through. The next photograph shows spalling on the floor, and this is the most common type of issue that you're going to find on a parking deck is the spalling. And the vast majority of the cost for maintaining and repairing a parking structure is going to be on the floor. Typically the columns are going to be okay, beams are going to be okay in general, but the vast majority of the cost is going to be on issues with the floor. And the reason for that is because the floor gets constant wheel loading from the cars, the traffic, and most of the parking structures are exposed to the elements. So you got the weather exposure and so forth. Here is an example of spalling of the underside of the deck, which is actually a little bit more severe condition because some of the spalling could be a falling debris hazard. So this is certainly something to pay attention to, and typically this type of distress condition is a high priority item because some of this could be a life safety type of issue. But again, most of the distress in the parking structure are going to be on the floor, and that's where the bulk of the repair and maintenance cost is going to go into. Another example of a spall in this particular case is because of shallow steel reinforcement. So sometimes you inherit a structure where the steel reinforcement wasn't properly placed, and because of water penetration of chlorides and so forth, it leads to corrosion and spalling, like in this photograph. Other types of condition are joint failures. Expansion joints is a big maintenance item, big repair item, and a lot of you are probably aware of this. So expansion joints they're expensive to maintain, to fix, and they take a beating and abuse over the years. But these are certainly some of the items, some of the issues that you'll see become part of the asset management on a parking structure. This photograph shows ponding. I mean, if you give water enough time, it'll pretty much eat through anything. So ponding on top of a deck is not a good thing. So having proper drainage is important to minimize the stress and extend the service life of the parking deck. Some other miscellaneous components like the stair steps. A lot of garages, they have steel framing for the stairs, and it's not a good system because they corrode, because these are exposed elements. And as a minimum, they present an aesthetic concern, but they also corrode to a point where they can become a structural problem and a life safety issue. So in many cases, what we do with the steel stairs is replace them with precast concrete stairs if possible, if the structure can accommodate the loads. Handrails, corrosion is a big issue. It's also a life safety type of concern. And typically the corrosion on handrails is going to be at the connection points. And many times they are not visible because a lot of times what the maintenance crew does, they paint over the corroded elements, and there's coats and coats of paint over, so you can't really see how much corrosion is going on. But certainly handrails is a life safety concern, and it needs to be considered as part of the asset management. Other components like trench drains. Some of the older garages, they have metal trench drains, so they weren't shown in the photograph, and they corrode with time. They leak. They're problematic. Nowadays, most of the parking decks that we design, we use floor drains as opposed to trench drains like this, also for loading considerations. Some other type of structure have a specific type issue like post-tensioning. They have leakage and corrosion and at anchors. Top left photograph, you can see on the right photo, you can see a post-tension tendon kind of shooting out of the side, and then corrosion of the post-tension tendon is also an issue. And I have a case study to illustrate this a little further. Precast concrete structures, they have specific issues with bearing. You can see the photograph on the left, either the ledger, the inverted T-beam on the top, or what's called the bearing pad, they move. And then also, as I mentioned earlier, these precast concrete structures have a lot of connections, and you see problems with connection constantly on these type of structures. Steel corrosion, another common problem that you're going to see if you're dealing with the steel frame garage. Again, steel framing is not the best system for the parking structure because they're not very durable. However, they do present a good option for a vertical expansion. Vehicle barrier failure. This is certainly a risk management for owners. Some of the older structures, the perimeter bumper walls are not properly designed for current code requirements. The size of the vehicles have changed over time. The SUVs have come into the picture, and the big pickup trucks. and the bumper load requirements have increased. So some of the older structures are not properly designed, and it can lead to significant failures like the one shown on this photo. Here's another photograph that shows a car that went over the side of the garage that had a cable barrier system. So these are also problematic. In this photo, the car looked like it's kind of floating in the air, but the resolution doesn't do enough justice. There is a cable there that is attached to the car that is keeping it floating there. But anyway, these cable systems can be problematic. And these are the cable system that are at 9 inches on center, and many of them don't comply with current code requirements, and can lead to this type of failures. So now that we looked at the types of distress condition and the prioritization of those, so let's talk about the plan and the execution next. So the plan is to essentially, after you as an owner, you have retain an engineer to do the assessment and give you a report telling you with a recommendation of what to do first and what can be done later. Then it's time to address that by executing a plan. And the first thing is a set of a report from an assessment is not intended to be a set of repair documents. I see in some cases some clients some owners that take our report and they give it to a contractor and say, okay, give me a bid to do these repairs. And what happened is that the contractors, they come up with bids that vary all over the place. And the reason is because the report doesn't have enough information for them to put together a bid, and it's not intended to do that. So what I recommend to the clients is to have the engineer put a set of documents together that clearly shows the intent of what the repairs are. And a good set of documents include floor plan that shows the specific locations where the repairs need to be done. It has the details that show how the repair is supposed to look like, and then a set of technical specification. Now, in some cases, a set of technical specs is not required. Like we have some clients where, in order to minimize the engineering cost, what we do is we put together the drawings with notes, and that's probably sufficient in many cases for certain projects where there's not too many structural type issues. So it can be accommodated as well to minimize the cost. And it's important also to have a procurement form where the contractors can go in there and provide the pricing information. And in some cases, some clients and owners, they like to have the construction period as a bid item. Sometimes the selection of the contractor is not so much a function of the cost, but who can do it faster. You know, the schedule many times drives the project. And then that's the second phase. So we talked about the first phase, which is the investigation. The deliverable from that is a report. Then we go into the plan, which is a set of repair documents. Now the execution is the actual construction work. And then there is a pre-construction period to select the contractor. And then during the construction period, the important thing here is to have the engineer involved to ensure that the design is met. So typically the way that I explain to my clients the construction phase services is kind of like an insurance policy. You know, you as an owner of this property, how much assurance do you want to have that the repairs being done are in line with the documents? And that's where the involvement of an engineering is important. So certainly having the engineering all the way from A to C is key to execute this project properly. Now let's go into some of the case studies to better illustrate. So I have, like I said, 3 to 5 based on time. We'll see how it goes. How many case studies we'll go through it. But certainly the case studies are probably the best way to illustrate some of the concepts. The first one here is related to structural type issues. So this is a garage parking structure, cast in place post tension in Chicago. And this parking structure looked really good, very little cracking. I mean, it looks in great condition. There was the previous owner had an engineer do an assessment and they didn't find anything wrong with it. It was just fine. And the new owner that came in, they hired us to take a look at it and give them an opinion as to what was going on. They just wanted a second opinion just to make sure everything was fine. So we started digging into it. We saw a little bit of cracking in some areas, not a big deal. Here, the client was a little bit concerned about some of the water that was going through. This particular one is a construction joint. And you can see kind of on the far end of that photo, a little bit of a white staining, which is called efflorescence. So we started digging into a little bit more, and we noticed that at some of the construction joints, the slab have actually was actually dropped about 1/2 inch or so. Here's a close-up of that. So a very subtle type of issue. So we started diving into a little bit more, and it turns out that this is what happened. This is a kind of schematic of what was going on. So it turns out that the slab actually deflected because the post-tension tendons broke, and what they did was add a repair patch to level it off. And it was a very little deflection, about 1/2 inch or so at the end to 1 inch. So essentially, we started looking into it. So this photograph, I want to direct your attention here where my cursor is. You can see that PT tendon shooting out. Here's a close-up. So certainly a failed PT tendon. So we saw one there and one at an expansion joint. So only 2 that were popped out like that. So that gives you certainly an indication that there are some broken tendons. Then we recommended to the client, well, let's do some inspection openings to find out a little bit more. So we do some inspection openings just to see the condition of the tendons. And the way to check the tendons is, these tendons, they are tensioned to a 30,000 pound force. So there is no way that if these tendons are tensioned, that you can take a screwdriver and drive it into it. So the way these tendons are built is basically 7 wires, steel wires. There is one in the center that is straight, and there's 6 others that are kind of weaved around it. And then they are tensioned to a 30,000 pound force. So you take the screwdriver, and if there is no tension on the tendons, you can drive the screwdriver and separate the wires. So that's the test we use. The other one is to use a crowbar. And if you can lift that tendon, certainly that tendon is an indication that it has failed, it's broken. So we did an assessment, and on this graph, it shows a plan view of one of the decks. And you can see everything that it has a red line is a failed tendon, and everything blue is a good tendon. So certainly a significant amount of tendons were broke. So it turns out that they have a significant structural deficiency in this particular project. So we had to do a repair in place, and this kind of shows the details that were used. So certainly a lot of big openings have to be made in the deck to accommodate essentially a tendon restressing type of scenario to address the structural deficiency. So several $100,000 worth of repairs to be able to address the problem. But what gave it away was a very subtle issue, which was that little drop of 1/2 inch or at the construction joints that most people would have missed, but certainly we didn't. So again, it's very important to properly assess the structure so that you don't miss something that could be an issue down the road. This case study number 2 is a little bit different. So this shows the photograph of, this is a parking structure, 10-story precast garage that had perimeter load-bearing columns. And these are photographs of a couple of those columns. So you can see the severe level of cracking. You know, it looks like kind of like a horror movie. And certainly the client, the owner, was concerned about the severity of the cracking because it looked pretty bad. So they had previously an engineer, a consultant that did an assessment, and they recommended replacement of the columns. And certainly that could be an option, but replacement columns of a structure that's in place is very costly, you know, several $1 million to be able to do that. So the owner wanted a second opinion. We came in to look at this. We started doing an investigation. So the first thing is to map out the cracks, just to establish some kind of connection between the structure and the pattern of the cracking. So this figure here kind of shows a elevation of the columns, and the red lines there are the cracks. So you can see a lot of cracking in certain areas close to joints. Then we started taking some core samples of the actual columns just to see the pattern of the cracking. And clearly, as you can see the photograph on the left side is the outside of the column, and the right side is the center of the column. So as you get closer to the center, the crack disappears, which is very good news for the owner because the strength of the columns is in the center. The outside is just for durability. This next one, we also did some ground penetrating radar testing, which is essentially intended to estimate where the steel reinforcement is located. And you can see here the red lines. the red line shows where the steel reinforcement was. So there was a lot of steel reinforcement kind of intersecting the crack, which is good news. So a lot of good news for the owner. We also took the samples, we sent it to a petrographer to do put it under a microscope. A petrographer is basically a scientist that looks at concrete under a microscope. And what they found is that there was an internal expansion mechanism that is activated under the presence of moisture. Kind of in a nutshell, that's what it is. So the mechanisms are called delayed ettringite formation and alkali silica reaction. I know that's a mouthful, but certainly basically what they are is an internal expansion mechanism in cured concrete in the presence of moisture. So what that means is that if we eliminate the moisture, we eliminate the mechanism, because without the moisture, this expansion doesn't occur. So instead of having to replace the column, what we came up with was a repair in place approach to minimize the relative humidity of the concrete by sealing the cracks and applying a surface sealer to minimize some of that water that was getting into it. Certainly that was a significantly less cost than having to spend millions of dollars to replace the column. So this turned out to be a couple of $100,000 versus several $1 million. Certainly there is a cost associated with the engineering fees, but that's a very small fraction of what replacing columns would have been in this project. So again, proper assessment of the cracking, even though they look very bad, it wasn't really a big issue. That is certainly very important on these parking structures. It looks like we're doing really good on time. So let's go through case study number 3. This one here is about a post-tension structure, and I've shown several photographs of that type of framing. Typically, the issues with the post-tension structures in parking garages are related to corrosion of the tendons. And a lot of the parking structures built prior to 1985, they had this type of sheeting that is shown on the red box right there, where a portion of the tendon was kind of exposed and not protected by the sheeting. So essentially, this is a cable that's inside the concrete structure that has some kind of protection around it, some kind of plastic sheeting. But the old type of system were not completely encapsulated, and they had sections that were exposed. And here's a photograph that kind of shows that strand. What was happening in this garage is that there was failure of the tendon. In this particular case, you can see a couple of those that have kind of come out of the end of the column. And many times that gives you a sign that there is a problem, but it doesn't tell you the full extent of the problem. So what we had to do is make some openings to check the rest of them. This is a beam that has 16 tendons. And it turns out when we did the opening that 7 of the tendons have failed. So, the first sign, it only looked like there were 2, but in reality were more than that. So we had to do some structural. So here's a close-up of the tendon. Anytime you see a tendon with the middle wire shooting out like that, that tells you that there is corrosion going on. That's the common failure mode. So we had to do some structural analysis to evaluate the condition and come up with the repair. We used a program called ADAPT, which is used for post-tension structures, and we kind of build a computer model of the framing to analyze it and come up with the repairs, which included the replacement of the tendons. Here is a hydraulic jack that was used to replace the tendons at the end of a beam. And then we also added some concrete cover. Nowadays, there is a different type of system that's more sophisticated, that's called the fully encapsulated system. In this particular case, because of restraint conditions in the field, we couldn't really implement that. So the next best thing was to add concrete cover for durability type reasons. So that was the case study. Let's see, it looks like we got a little bit of time here. Let's go through case study number 4. This particular one is a steel frame parking structure with a composite deck, and you can see severe corrosion of the beams and the columns on this photograph. Here's another close-up. Even the deck, the composite deck itself, which is providing structural capacity, was corroded. Some of the columns have severe section loss. You can see the photographs on the left. You can basically see a hole through the web of the column. Same thing with the photograph here on the right. So severe corrosion of these columns. So here's another one. So essentially what we had to do here is a repair in place type of program. So we had to analyze the structure, and we were able to come up with a way to salvage the structure instead of completely tearing it down because of the severe corrosion. So certainly a repair in place type of program is many times more doable than having to completely repair or replace the structure, even though the distress condition looked very severe. So we implemented a repair in place program with additional cover plates, and here's a detail that shows that, and also stiffening the base of the columns that were severely corroded. I think we have, let's go. So we have another case, a couple of more case studies. This one real quick. This is the type of framing that has the open web steel joists and the form deck. So you can see here in this photograph, severe amount of cracking on the floor. So in this particular case, the repair program was to replace the entire deck with a new deck. And here's a photograph of the new deck. And then the moist curing was critical here during construction to minimize the amount of cracking. So certainly the construction phase was, involvement in the construction phase was key to make sure that the work was done in accordance with the documents. And there was also a traffic coating system that was that allowed breathability or allowed moisture to migrate. That was before and that was after. So it improved aesthetics as well. So to wrap it all up, the key points of this presentation is a proactive approach is better than reactive. And also the investigation report is not intended to be used as a set of construction documents, as we talked about. And probably the most important thing to get out of this presentation is that probably the proper determination of the significance of the distress can save a lot of money. And also perform repair work during low usage, like right now, because of the pandemic, could save 15 to 20% roughly on the cost of repairs. And to wrap it all up, I'm going to quote this guy, the most interesting man in the world, when he says, I don't always do parking restoration, but when I do, I always take a proactive approach and hire an engineer. That's my way to go about it. So with that, here's my contact information. Certainly, if you guys are interested in having a roundtable discussions with your group or a presentation on a specific topic with your team, please don't hesitate to contact me. And I guess probably it's a good time to go into questions. So Becky, do we have any questions?
We do, Al. The first one is, on the Walker 10-year asset management report, how does Walker typically determine unit costs?
So the unit cost is determined based on data, a database that we have developed from actual projects throughout different geographic regions in the country. So this is, for instance, if the project is in New York, we actually have cost data for that geographic location that accounts for union labor and so forth. So it's based on experience. So that's how we come up with the unit cost for the repairs in the cost tables.
Great. Any other questions you can throw in the chat? Leon, I saw that you had raised your hand. If you want to ask your question in the chat or over audio, either way is fine. Great, Leon, feel free to chime in. Al, do you, in your experience, what is one of the first, oh, go ahead, yes.
Sorry, I was just going to ask more broadly, do you recommend doing one item like concrete repair, kind of start to finish from one end to the other, or really focusing in kind of one level or one phase by phase, and doing everything at once? I've seen kind of both ways.
Yeah, and that can go both ways. I think certainly the most owners like the approach of starting on one level. And typically, if it's an open structure, start at the top level and work your way down. Especially the issue is the water infiltration type problem from the top down. So that certainly makes sense, especially when you want to keep the structure, maintain the structure in service during the repairs, because you can shut down a certain section of the garage and keep the remaining open. Now, if the garage is shut down or is not being used, like in the case that it is now for many parking structures, I think going about doing all the repairs that you can at once, one particular repair, let's say you address all the concrete in one shot in all levels, that might be the most cost-effective way. But it really depends on how much of the structure is available for repairs.
Thanks, Al. Leon, do you have any follow-up, or does that answer your questions?
No, I'm good. Thanks so much.
Sure. We'll open it up to any other questions. I see some coming in. Michael Boyle is asking, what degree of accuracy do you see in your 10-year planning? How often do you recommend updating for an annual capital planning program?
Yeah, that's a great question. And because of it, remember when I showed that deterioration curve where the cost goes up exponentially? So sometimes I see a client, an owner says, well, let's do an assessment and give me the 10-year plan. So we do that, we provide the plan. 3 years later, they come back and say, okay, let's execute the plan. Well, what happened is what we saw 3 years ago is not the condition that it is now. It's probably a lot worse. So we had to go back and restart again and do another assessment. The accuracy of the plan it can be very good if there is periodic assessment. I typically recommend doing assessment every 2 to 3 years. And that depends on the age of the structure. Typically, structures that are over 20 years old, you want to do more frequent. If it's less than 20 years, you probably don't need to do as many. Maybe 3 to 5 is probably okay. But yeah, I think the accuracy is good as long as there is a periodic assessment to update it.
Great. Thanks for the question, Michael. Did you have any follow-up? Let us know if you do. Another question from John Carroll. Al, can you elaborate on how failed PT tendons are repaired or replaced?
Sure. So the replacement option, well, the way they fail typically, as I mentioned, the mechanism is typically corrosion, because these post-tension tendons are more sensible kind of at the ends of the members, which in some cases are exposed to the elements. Particularly the older type of systems that don't have the fully encapsulated system around it, and they're a little bit more sensitive to chloride attack and then the corrosion. So that's the failure mechanism. In terms of repairs, there's multiple ways. If you're dealing with an unbonded system, replacing the tendons can be the way to go. Now, in some cases, what happens is there is a phenomenon called the tendon sweep. So that means that the tendon moves during the failure, in which case it loses the original path that it had. So in cases like that, where the tendon sweep and sometimes they take the space of another adjacent tendon, it's not really feasible to replace it. So in lieu of that, many times you can do an external post-tensioning, or you could do potentially a carbon fiber reinforced polymer type of repair. It's more of a structural type of repair. So there's multiple ways depending on the specific conditions, but ideally replacement is the way to go. And the way to do that is, if it's a tendon that you take out, you put a new one in, you want to go in with a smaller diameter tendon. And so there's got to be a structural analysis involved to make sure that the smaller diameter tendons are adequate to meet the load requirements. So sometimes it's a combination. You add new tendons and also have to do something to re-strengthen it. But yeah, there's a couple of ways to do the actual repairs. Hopefully that answers your question.
Thanks, Al. Here's another question from Sunny Fight. What did you do with the corroded steel decking in the last case study?
So in that, we basically, we had to replace some of the sections and essentially overlap a new metal deck that matches the profile of the previous, the deck that was in place, to strengthen the deck. Because in that particular case, it was a composite deck, so you are relying on the metal to provide the structural capacity. So we had to essentially compensate for that. In some cases, the metal deck is just form work. It's just a form deck. Then the corrosion is not very critical. In that particular case study, it was, so we had to do a repair in place for that, which is doable. It can be done.
Great. Another question, since some level of cracking occurs on most garages, what amount raises a red flag? the significant water intrusion through the slab always require further investigation.
Yes, and again, the level of cracking, the amount of cracking is not such as important as the type of cracking. You could have a deck with just one crack that may mean that there is a structural problem. Typically, post-tension structure, when you see cracking, especially if it's what's called a faulted crack, where you see the elevation of the crack on one side is higher than the other, that's typically an issue. It can tell you there are some broken tendons, which could be a big problem. And in some cases, you see a lot of cracking around columns on the cast-in-place concrete frame, and they're just restrained cracking that don't really have any structural significance. So sometimes, and I showed the example of the columns that had a lot of cracking, and in that particular case, it was more of a durability that the issue, wasn't really a structural problem. So it's more about what's the significance of the cracking, what's causing it, and to really understand the cracking mechanism is the key. In some cases, the cracking mechanism is just restraint to thermal movement. So in that case, what you have is a crack that's through the thickness of the element, and that is more, that makes the structure a little more susceptible to water infiltration. So that presents a durability type issue. Typically, the structural cracks are not through thickness. So that's one way of telling whether you have a structural problem or not. But really, it's more about what's the mechanism, what's causing the crack that dictates, what the significance is.
That makes sense. So it's not about the volume necessarily, but the root cause of it.
Right. Correct.
Great. That's all the questions we have in the question forum. Are there any others? Feel free to raise your hand or throw them in the chat. Great. Al, any closing thoughts?
No, I guess just to wrap it all up, again, there's many, we kind of went through these case studies. We can probably spend an hour on each one of these and kind of dive into the nuts and bolts of the issues. So certainly, if anybody's interested in talking more about these case studies, you have any further questions, feel free to reach out to me, and be glad to help you with that. The other thing is we're going to follow up with we talked about some of the tools that we're going to provide to you that can help you manage the maintenance and repairs of your garages. So we will follow up with a checklist of items that you can do with your maintenance crew, and that checklist is a function of things that you can check daily, monthly, and annually. And that can help you manage your parking structure, certainly help keep that deterioration curve as flat as possible. So we'll make that available to everybody. We'll send an email. So I think, Becky, will you have that the process for that, right? I think it will be sent through email.
Yes, that's right. We'll follow up with the follow-up document, and we'll also send a link to the presentation. So you have both of those tools. And I think that's everything. Thank you so much, everyone, for attending. We appreciate your time and your attention. And thank you so much, Al. Lots of comments about it was a great presentation. So thank you.
Thanks, everybody.